if A is the first term and D is the common difference, if the common difference is same throughout the sequence, then that is called as the arithmetical progression. If the number of elements in the sequence are finite, then it is called a finite sequence. If the number of elements in the sequence are infinite, then it is called as the infinite sequence. Nth term of a GP denoted as Tn. The nth term of a geometric progression is r to the power of n minus 1. Hello dear students, welcome to this session of Discrete Mathematics class. I am Mr. Niranjan, Faculty, Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence. Now in this session I am going to discuss regarding very important concept, that is sequence and the summation of the sequences. Now before going to the summation, let us know regarding the sequence. What is meant by a sequence? Now how to define the sequence? So the arrangement of numbers one after the another according to some rules is called the sequence of a number, or that can also be defined as sequence is a real valued function whose domain is the set of all natural numbers. The domain is a set of all natural numbers. So now let us consider, for example, suppose if A1, A2, A3, etc., AN are the elements where A1 is called the first term, A2 is the second term, and etc. There are n terms. AN is called the nth term. Let us take, for example, even numbers up to 10. So that is 2, 4, 6, 8, 10. This is the sequence. So here 2, 4, 6, 8 are the even numbers. They are arranged according to some rule. So the difference between two numbers is 2. 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 2 is 8, 8 plus 2 is 10. So here this 2 is called the first term denoted as A1, and 4 is the second term A2, 3, 6 is the third term A3, and fourth term A4 is 8, and the fifth term A5 is 10. So therefore A1, A2, A3, A1, A2, A3, A4 and A5 are called as the terms of the sequence. These are called the terms of the sequence. So the number in the sequence are called as the terms of the sequence, and the last term is denoted as Tn, that is called as the nth term. The nth term is denoted as Tn. Tn is called the nth term of the sequence. So here the first term A is equal to 2 and the last term nth term Tn is equal to 10. The last term Tn is equal to nth term. So this arrangement of numbers according to a particular rule, that is the arrangement of numbers one after the another according to a certain rule, is called as the sequence. So these are called A1, A2, A3, A4, etc. are called as the terms of the sequence. A1 is called the first term and A2 is called the second term, etc. The last term is called the nth term of the sequence denoted as capital Tn or small tn. Now let us come to the important concept, finite and infinite sequence. What is meant by a finite sequence and infinite sequence? Finite means if the sequence has a finite number of terms. If a sequence having finite number of terms, then such a sequence is called a finite sequence. If it has infinite number of elements, then it is called as the infinite sequence. The sequence which has infinite number of terms, then it is called as the infinite sequence. Let us consider, for example, let us write this: 2, 4, 6, 8, 10, 12. So here the number of elements are finite. This contains 1, 2, 3, 4, 5, 6. So this contains finite number of elements. Therefore, this is called as a finite sequence. Whereas if I write the same sequence in this form, 2, 4, 6, etc., then this is called as an infinite sequence. So here the number of elements are not defined. So not particularly defined the number of elements. Here the number of elements are up to 12. 1, 2, 3, 4, 5, 6 elements are there in the sequence. So therefore this is called a finite sequence and this is called an infinite sequence. So finite sets and infinite sets means if the number of elements in the sets are finite, then it is called a finite set. If the number of elements are not defined, infinite, then it is called as an infinite. So similarly, if the number of elements in the sequence are finite, then it is called a finite sequence. If the number of elements in the sequence are infinite, then it is called as a infinite sequence. So this is an example for a sequence which is finite and a infinite sequence. Okay. Now let us take an example based on this. Write the first three terms in each of the following sequences defined by the following, the nth term, here the nth term of the sequences are given. We have to write how many terms? So first three terms means A1, A2 and A3 we have to write. Now what is given? An is equal to 2n plus 5. Put n is equal to 1. You will get A1 is equal to 2 into 1 plus 5. That is 2 plus 5 is 7. Put n is equal to 2. If you put n is equal to 2, A2 is equal to 2 into 2 plus 5, that's equal to 4 plus 5. 4 plus 5 is equal to 9. And put n is equal to 3. If you put n is equal to 3, you will get the third term. A3 is equal to 2 into 3 plus 5, that's equal to 6 plus 5 is equal to 11. So, therefore, the three terms are, that is 7, 9 and 11. So, this is called a sequence. So, here 7, 9 are arranged according to a particular order. So, this will form the sequence. So, the three terms of the sequence 2n plus 5 is 7, 9 and 11. That is the first three terms. So, similarly come to this example. So, to write the first three terms of the sequence, put n is equal to 1, 2 and 3. Then you will get, if you put n is equal to 1, A1 is equal to, A1 is 1 minus 3 divided by 4. This is minus 2 by 4 is minus 1 by 2. Now, put n is equal to 2, you will get A2 is equal to 2 minus 3 divided by 4. This is equal to minus 1 by 4. If you put n is equal to 3, the third term A3 is equal to 3 minus 3 divided by 4. 3 minus 3 is 0 divided by 4 is equal to 0. So, therefore, the terms of the sequence are minus 1 by 2, minus 1 by 4 and 0. These are the first three terms of the sequence whose nth term is n minus 3 divided by 4. See here. So, the first three terms of the sequence an is equal to 2n plus 5 is 7, 9 and 11. 7, 9 and 11. Similarly, the first three terms for the given sequence an is equal to n minus 3 divided by 4 is minus 1 by 2, minus 1 by 4 and 0. These are the three terms of the sequence. Okay. Now, let us come to the next problem. What is the problem? What is the 20th term? So, we have to find the 20th term of the sequence whose nth term is given. What is given? An is equal to n minus 1 into 2 minus n into 3 plus n. This is given. Now, put n is equal to 20. If you put n is equal to 20, you will get A20 is equal to 20 minus 1, 2 minus 20 into 3 plus 20. Add this. So, 20 minus 1 is 19, 2 minus 20 is minus 18 into 3 plus 20 is equal to 23. Multiply this. 19 into 18 into 23. Just multiply, you will get the answer. That's it. So, if you multiply this, we will get 7866 along with negative number. So, the 20th term of the sequence is minus 7866. Okay. That's it. Now, let us come to the next problem. What is the sixth term of the sequence defined by n is equal to 4n minus 3. Another one is n is equal to n cube divided by 2 to the power of n. Now, here also the sixth term we have to find. Put n is equal to 6. That is A6 is equal to 4 into 6 minus 3. 6 4s are 24 minus 3 is equal to 21. So, A6 is equal to 21. So, the sixth term is 21. Here, put n is equal to 6. If you put n is equal to 6, A6 is equal to 6 to the power of 3 divided by 2 to the power of 6. So, 6 cube divided by 2 power 6. Let us multiply this. 6 into 6 into 6. So, this is 6 into 6 into 6 divided by 6 times multiplied by 2. 2 multiplied by 6 times. 2 into 2 into 2 into 2 into 2 into 2. 1, 2, 3, 4, 5, 6. So, 6 into 6, 36 into 6 is 216 divided by, multiply 2 to the 4, 4 to the 8, 8 to the 16, 16 to the 32, 32 into 2 is 64. Otherwise, you can divide like this. 2 3s are gets cancelled. Again 2 3s are gets cancelled. 2 3s are gets cancelled. So, that is 3 3s are 9 3s are 27 divided by 2 2s are 4 2s are 8. 27 divided by 8 you will get. So, this is 27 divided by 8. That's it. So, if n is equal to 6, we will get 6 to the power of 3 divided by 2 to the power of 6. That can be written as 27 divided by 8. That's it. This is how we are going to simplify this. Now, let us come to the next concept, that is very important, arithmetic progression, AP. You might have been studied in your previous classes, AP, GP and HP in progressions, arithmetic progressions, geometrical progressions and harmonic progression. Similarly, arithmetic mean, geometrical mean and harmonic mean. Same thing we are going to study here also. Now, let us know regarding the concept of AP first, arithmetic progression. What is arithmetic progression? You might have been studied, if A is the first term and D is the common difference, if the common difference is same throughout the sequence, then that is called as the arithmetical progression. A is the first term and D is the common difference. So, here a sequence of the form A1, A2, etc. AN is called arithmetical sequence or arithmetical progression if the common difference is same. If the common difference is equal to same, then it is called as the arithmetical progression or arithmetic sequence. So, arithmetic sequence or arithmetic progression where the common difference is same. Here, A is called the first term and the constant difference term is called as D. D is called the common difference of the AP, arithmetic progression. Now, let us consider an AP in the standard form. If A is the first term and is the common difference, then the terms of the sequence are A plus D, A plus 2D, A plus 3D, etc. we will get. If A is the first term and D is the common difference, then the sequence, the terms of the sequence AP are A plus D, A plus 2D, A plus 3D, etc. A plus N minus 1 into D. So, here the last term A plus N minus 1 into D is called the nth term. That is called the nth term. So, the nth term of an arithmetical progression is denoted as Tn is equal to A plus N minus 1 into D. The nth term of an AP is Tn is equal to A plus N minus 1 into D. So, if A is the first term, D is the common difference, the terms are first term T1, T2, T3. First term T1 is A, second term T2 is A plus D, the third term T3 is A plus 2D, etc. The nth term is denoted as A plus N minus 1 into D. That is called the nth term of an AP is A plus N minus 1 into D. Now, similarly, suppose if n term, the sum, to find the sum of n terms of an AP, the sum of first n terms of an AP with the first term A and the common difference D is Sn is equal to n by 2 into 2A plus n minus 1 into D, or Sn is equal to n by 2 into A plus L, where L is the last term. Okay. So, this is how we are going to find the sum of n terms of an arithmetic progression. Let me take an example. If 1, 3, 5, 7, etc. is in AP, Now, check whether it is in AP or not. What is the first term? A is the first term. A is equal to 1 and the common difference is second term minus first term. 3 minus 1 is 2. Similarly, if you check 5 minus 3 is also equal to 2. 7 minus 5 is also equal. So, A is the first term and the common difference A is 1 and the common difference D is equal to 2. Now, suppose if you want to find the fifth term, Tn is equal to fifth term of the AP. Tn is equal to, what is the formula we are going to use? A plus N minus 1 into D. A is 1, N is 5 minus 1 into D. D is equal to 2. So, this is equal to 1 plus 5 minus 1 is 4 into 2, that's equal to 1 plus 4 to the 8, that's equal to 9. So, the next term you are going to get is 7 plus 2, 8 and 9. Suppose if you want to find the 20th term of this arithmetical progression. So, that is T20 can be written as A. What is A? A is 1 plus N is 20 minus 1 into D is 2. So, this is 1 plus 20 minus 1 is 19 into 2, that is 19 into 2. That's equal to 38. 38 plus 1 is 39. So, the 20th term for the given sequences, the 20th term is 39. So, like this we are going to find the nth term of a given arithmetic progression. So, if A is the first term and D is the common difference of an AP arithmetic progression, then the nth term is given by Tn is equal to A plus N minus 1 into D. Now, to find the sum of n terms, we are going to use Sn is equal to n by 2 into 2a plus n minus 1 into d. Now let us take a problem on that. Now find the sum of all natural numbers lying between 100 and 1000 which are multiples of 5. So the values lying between 100 to 1000 and they are also the multiples of 5. For that we are going to find the sum. So sum of all natural numbers between 100 to 1000 which are multiples of 5 is to be determined. Now first find out the first number which is multiple of 5. So after 100 and find the number before 1000 which is multiple of 5. That's it. Okay. So the first number which is multiple of 5 from 100 is 105. Then the next term is 110. The next term is 115. So 105, 110, 115, etc. The last term is 995. Now listen. What is to find here? The sum. Now we have to find the sum. Sum of 105 plus 110 plus 115, etc. The last number is 995. Now write down what is the first term. A is equal to 105. This is an AP with the common difference is D is equal to 5. The common difference is 5. So this is an AP is an arithmetic progression where the first term is 105 and the common difference is 5 and the last term L is equal to 995. We don't know the number of terms. N is to be determined. First find out the N value of N, the number of terms. Now we know the nth term Tn is equal to A plus n minus 1 into D. So the last term we know the nth term is 995 is equal to A. The first term is 105 plus n minus 1 into the common difference is 5. Simplify this. So this can also be written as 995 minus, I'll go to the next page, see here, 995 minus 105 is equal to n minus 1 into 5. So 995 minus 105, 5 minus 5 0, 9 minus 0 is 9 and 9 minus 1 is 8. 890, just multiply it, 5n minus 5. Transfer this, 890 plus 5 is equal to 5 times n. So 5n is equal to 895. So therefore n is equal to 895 divided by 5. Just divide 895 by 5, you will get the value of n. So exactly it will divisible by 179 times. So 895 divided by 5 is n is equal to 170. So the number of terms are 179. Now just find out the Sn. What is the formula for Sn? Sn is equal to n by 2 into 2a plus n minus 1 into d, or there is one formula Sn is equal to n by 2 into, so we know the formula for Sn is also equal to n by 2 into a plus l. So what is here? N is equal to 179. 179 divided by 2 into the first term. What is the first term? First term we have is 105. 105 plus the last term. What is the last term? We have 995. 995. Add this. 179 by 2 into, if you add, so that is 995 plus 105. This is 0, 9, 10, 11, 1100. So this is 179 into divide by 2. So what you will get? 1100 is nothing, divided by 2 is 550. So if you multiply 179 into 550, you are going to get the answer. That's it. So if you multiply this, you will get 98,450. So therefore, the sum of all natural numbers lying between 100 to 1000 which are multiples of 5 is 98,450, which is the required answer. Okay, the number of terms are 179. That's it. Hope you followed. This very important problem for 5 marks. You may expect this type of questions for 5 marks. Okay, let us take one more problem. Suppose if you want to find the sum of 1 plus 3 plus 5 plus 7 up to 10 terms. Now suppose if you want to find the sum of this arithmetical progression, what is given? A is equal to 1, the common difference D is equal to 2 and n is equal to 10. So just find out the sum. Sn is equal to n by 2 into 2a plus n minus 1 into d. So S10 is equal to n is 10 by 2 into 2 times a is 1 plus n is again 10 minus 1 into d is 2. So this is 10 by 2 into 2 plus 10 minus 1 is 9 into 2. So this can also be written as 10 by 2 is 5 into 2 plus 9 2s are 18. So this is 5 into 18 plus 2 is 20. This is equal to 100. So the sum of all numbers 1 plus 3 plus 5 etc. up to 10 terms is 100. So this is the 10th term. Suppose if you know the last term, you can take the formula Sn is equal to a plus L as the last term. That what we did in the previous problem. Let us come to the next concept, the geometrical progression, GP. So geometrical progression, GP. Now how to define? So in GP, if A is the first term and R is the common ratio, whereas in arithmetic progression D is the common difference, whereas in GP we will get the common ratio. That's it. So a sequence of non-zero terms is called a geometric progression if and only if the ratio of any term to its preceding terms is constant. If the ratio is constant, then such a sequence is called as the geometric progression, and the constant term is called as the common ratio denoted as R. So here suppose if A is the first term and R is the common ratio, if R is the common ratio, how to find the common ratio? Common ratio is equal to second term divided by first term, that is any term divided by its previous term will give the common ratio. Suppose if A is the first term and R is the common ratio, then the sequence A, AR, AR square, AR cube, etc. AR to the power of n minus 1 is called the geometrical progression. The sequence of the form A, AR, AR square, AR cube, etc. AR to the power of n minus 1 is the terms of the sequence, that is called a geometric progression. Here A is called the first term and R is called the common ratio, and AR to the power of n minus 1 is called the nth term of a GP denoted as Tn. The nth term of a geometric progression is AR to the power of n minus 1. The nth term of a geometrical progression, is AR to the power of n minus 1. Now let us come to the general term of a GP. As I explained, let A is the first term and R is the common ratio of a geometric progression, then the general term or nth term of a geometric progression is denoted as Tn, and it is given by Tn is equal to AR to the power of n minus 1. Let us take a small example. Example 1, 2, 4, 8, etc. Now this is a geometric progression. Verify whether this is a GP or not. Here what is the first term? A is the first term and the common ratio R is equal to second term by first one. So 2 by 1 is 2. Similarly 4 divided by 2 is also 2. 8 divided by 4 is also. So this is a geometrical progression. Okay. Now to find the nth term of such a geometrical progression, the nth term Tn is equal to AR to the power of n minus 1. What is A? A is 1. R, what is R? R is 2 to the power of n minus 1. So this is 1 into any number is the same, 2 to the power of n minus 1 is the nth term of this given geometric progression. So to find the nth term, we are going to use the formula AR to the power of n minus 1. Okay. Let us come to the next problem. Find the 12th term of a GP and whose 8th term is 192 and the common ratio is 2. So what is required to find is 12th term. T12 is to be determined. Find the 12th term of a geometrical progression whose 8th term is given. 8th term is 192. That means T8 is equal to 192 and the common ratio R is also given, that's equal to 2. Okay. Now find the 12th term of a GP whose 8th term is given. So we know what is the nth term. Tn is equal to AR to the power of n minus 1. The 8th term, put n is equal to 8. So Ti is equal to A into the common ratio is given 2 to the power of 8 minus 1. What is T8? That is 192 is equal to A into 2 to the power of 7. So here 192 is equal to A into 2 to the power of 7. Simplify this. 2 to the 4, 4 to the 8, 8 to the 16, 16 to the 32, 32 into 2 is 64. So 2 to the power of 4. 1, 2, 3, 4, 5, 6, 7. 2 to the 4, 4 to the 8 to the 16, 16 to the 32, 32 into 2 is 64, 64 into 2 is 128. So 128. So therefore A is equal to 192 divided by 128. So this can be written as 3 by 2. So if you divide, you will get 3 by 2. So here A is equal to 3 by 2. The first term is 3 by 2. Now by knowing, now A is equal to 3 by 2, the common ratio is 2. A is equal to 3 by 2 and the common ratio is 2. What is required to find is the 12th term. T12 is the term to be determined. T12 is equal to Tn is equal to r to the power of n minus 1. Put n is equal to 12. T12 is equal to a into r to the power of 12 minus 1. That is T12 is equal to, we know what is A. A is equal to 3 by 2 and R common ratio is 2 to the power of 12 minus 1 is 11. So this can be written as, so 3 into 1 by 2 into 2 to the power of 11. So this gets cancelled. 3 into 2 to the power of 10. 3 into 2 to the power of 10. Simplify this, you will get the answer. That's it. So you know 2 to the power of 10 is 1024. 3 into 1024. So that is nothing but multiply this. 3 4s are 12, 3 2s are 6 plus 1 is 7. So that is equal to 3072. So 3072 is the required answer. That's it. So therefore the required answer T12 is equal to 3072. That's it. Okay. Hope you followed. That's all. See here. The 12th term is to be determined whose 8th term is given. Since 8th term Tn is equal to a to the power of n minus 1, T8 is 192 is equal to a into 2 to the power of 8 minus 1 is 7. So 192 is equal to a into 2 to the power of 7 is 128. A is equal to 192 by 128 is 3 by 2. So since the first term is 3 by 2, our common ratio is 2 and the 12th term is to be determined. So formula for the nth term is a to the power of n minus 1 in a GP. So T12 is equal to a into r to the power of 12 minus 1 is 11. A is 3 by 2, r is 2. So 3 by 2 into 2 to the power of 11. This is 3 into 1 by 2 into 2 power 11. 1, 2, 2 gets cancelled. 3 into 2 to the power of 10. Since 2 to the power of 10 is equal to, you know, 2 power 10 is equal to 1024. If multiply by 3, you will get 3072. So therefore T12 is equal to 3072, which is the required answer in this given geometric progression. That's it. These are few problems based on arithmetic progression and geometric progression. That's all regarding today's session. Let us meet with few more problems in the next session. Thank you. Thank you very much.